To be able to calculate interest as an amount of money, we need to know a few things besides the interest rate, which is normally expressed on an annual basis. We also need to know the principal and the duration, but it doesn't stop there. We additionally need to know the frequency with which the interest is applied and paid, whether there is simple interest or compounding interest, and the kind of loan or investment we're looking at. For example, whether it is repaid lump sum or in installments. I've explained what these things are in a previous video. Link in the description. So let's put together a worked example to show you how this is done. Keep in mind that we'll keep the principal, the interest rate, and the duration exactly the same. We'll be looking at 3 cases, all of which are with compounding interest. The first 2 cases are loans which have to be repaid at maturity after 3 years in one big sum, including the principal and all interest. This is known as a deferred interest bullet loan. In the first case, we'll assume that interest compounds yearly. In the second case, we'll have monthly compounding. The third case is an installment loan in which the principal is repaid together with the interest in equal monthly installments during the 3 years, so there is no lump sum to be repaid at the end. Okay, let's have a look at our 3 cases, which are the deferred interest bullet loan with annual compounding, the deferred interest bullet loan with monthly compounding, and the installment loan with monthly compounding and repayment. In all cases, the principal is $10,000, we're setting the interest rate at 12% per year, and the maturity of the loan to 3 years, starting in the present, which we'll call end of year 0, EOY 0. Let's assume that in all 3 cases we are the lender, so the principal appears as a negative cash flow and the interest and repayments appear as positive cash flows. That means at EOY 0 we have a negative cash flow of $10,000, which gives us a balance of $10,000 at that time. To make the example simple, we'll sum up what happens in each year, so we're showing the total cash flows at EOY 1, EOY 2 and EOY 3. Considering all of this, it would be reasonable to assume that the total amount of interest would also be the same, or at least similar, right? Wrong. Let's work this out. In the first case, we compound annually, reapplying our 12% interest 3 times at EOY 1, EOY 2 and EOY 3, leaving us with a total balance of $14,049 at maturity, which is then repaid, resulting in the cash flow. If we subtract the principal from this, we can see that we've received a total of $4,049 of interest. In the second case, we compound monthly. That means in each year we compound 12 times with an interest rate of 1%, which is 1/12 of the stated annual interest rate. Just this difference in compounding frequency increases the amount of interest, bringing us to a total balance of $14,308 at EOY 3, which means that the total interest due is now quite a bit higher at $4,308, which we again get by subtracting our principal. The third example works differently, however. Here the loan is repaid in monthly installments, with monthly compounding determined by the equated monthly installment method. We apply the interest rate and the equated monthly installment each month to determine the monthly balance. The figures for EOY 1, EOY 2 and EOY 3 show how the balance at the end of each year is reduced over time to 0. The total annual repayments are the same in each year, in this case $3,986, made up of 12 monthly repayments of $332. I'm rounding to the nearest dollar. These installments are made up both of principal repayment and interest. If we sum up all repayments and subtract the principal, we can see that the total amount of interest due is $1,957, which is quite a bit less than in the other cases. So, what does our little example tell us? First, the relationship between total interest paid and the interest rate isn't simple and depends on a number of things. We've seen that these things can have a big effect. Most people know that a low interest rate is favorable when they're a borrower and a high interest rate is favorable when they're a lender. But really understanding what you're signing up to when taking out a loan can be complicated. Second, with compounding interest, how often compounding happens matters. Just increasing the compounding frequency, which may seem like a minor detail, can quite strongly influence the total amount of interest. As a side note, compounding interest tends to have a large effect if the duration of the loan or investment is very long. This point is central in personal finance, especially where people are often advised to make investments over many years. Third, it really matters if a loan or investment is installment or non-installment credit. Chances are that the installment loan will have a far lower level of interest simply because the principal is paid back over time and interest can't build up as quickly. Other points to mention are perhaps that we've ignored inflation and we also haven't looked at any changes to the relative value of money over time. On a more practical level, we've also ignored fees and other charges that borrowers or investors often face. To inform people about these extra costs, it's often compulsory for lenders to state effective measures or metrics of interest. Examples could be the average percentage rate, APR, or the annual percentage yield, APY. I hope you got something out of this short video on interest. As always, thank you for watching.